All right, guys, so we're finishing up the review sheet today. So the next thing we're looking at is addition and subtraction, adding and subtracting rational expressions. Now, when we add or subtract rational expressions, the main thing is that the denominators have to be the same. It doesn't matter what form they come in. It could be already factored. As long as the denominators are the same, we can add or subtract the numerators. So here, both denominators are already 2x minus 1. So it means we can subtract our numerator terms. Now, normally with subtraction, we would put parentheses around both, but because it's a single term, we don't have any issues with distributing the negative. So here, since the denominators are already the same, we can go on and subtract the numerators. Now, the numerator of this here, 4x squared minus 1, is factorable. Specifically, it is a difference of perfect squares. Because 4x squared can be written as 2x and 2x, and then we have 1 and 1. Which does give us something in common on top and bottom. The 2x minus 1 and 2x minus 1 will cancel, leaving us with 2x plus 1. And that's it. There are going to be some of our polynomial functions on the test that are already factored, or sets of parentheses. If they're already factored, there's no reason to multiply them out. Leave them factored. Questions on 20 before we look at 21? So at 21, all three denominators, we do have three of them, are the same. So we can add the numerators. So we're going to be adding 9x squared, our 6x minus 1, and 6x plus 5 together. Now looking at the numerators, 9x squared does not have any like terms. But our 6x and 6x give us 12x. Telling us that we have 9x squared plus 12x plus 4, which is indeed factorable. Since the third term is positive, our signs are the same and match the sign in the middle term. Yes. Because factors of 9 are 1 and 9 or 3 and 3, but if we're wanting something to cancel, we're going to have to try to match it up with 3x plus 2. So going with the 3 and 3. Now, since we only have one of them on bottom, it'll only cancel with one of the ones on top, leaving us with a single 3x plus 2 on top. Now, we could put over 1, but we don't necessarily need it. It's understood. But if the 1's on top, everything simplified on top, we do need it on top. We just finished 21. Questions on 21 before we look at 22? No, you're good. Now, again, I'll say this. If something's factored on the test, because there are certain points or parts of it, I gave it to you already factored. So it could show up like this here. Yeah. Because, I mean, it could show up in this here. It's already factored. We don't have to do anything to it because the parentheses, that polynomial, they've been factored. You don't have to multiply back out. It's done. Because if it is factored like this here, we can move on and start the problem. Because all it's done for us is here, we can see the denominators aren't the same. So we have x squared plus 5x minus 14. Now we need to factor. Since the third term is negative, our signs are opposite. Factors of x squared would be x and x. Now our factors of 14 are 1 and 14 or 2 and 7. So I'm going to set the 7 as positive, 2 as negative, and we'll check. X times negative 2 would be negative 2x. 7 times x would give us a positive 7x. And negative 2x plus 7x would give us the positive 5x. So those are the correct factors. Now, for us to be able to add or subtract, we need the denominators to be the same. It doesn't matter if they already have sets of parentheses, because if the one on the right already had x plus 7 times x minus 2, they would be the same. We can add them. But the one on the right is missing a factor of what? X minus 2. So here, to get the denominators to be the same, we're going to have to multiply the top and bottom of this expression, the one on the right, by x minus 2. We don't have to do anything to the one on the left. Because it already has the least common denominator of x plus 7x minus 2. The one on the right is missing that x minus 2, so we have to multiply it on top and bottom. Now on bottom, we can just stick them together, multiply them together. We don't have to multiply that out, because if there is something in common on top and bottom, we need the denominator factored. But the numerator, we have to multiply through, because there's a chance we might have like terms. Our x times x is x squared. X times negative 2 is negative 2x. 3 times x is plus 3x, and 3 times negative 2 is negative 6. Now, before we start subtracting, we do need to combine like terms on top. Now, the first one, there are no like terms, but the second numerator, our negative 2x plus 3x, are like terms. There we go. Because after we combine those like terms, we get this here. This here? Yeah. Now that we have them simplified, we can subtract. Now, since we do have more than one term, especially on that second rational expression, putting parentheses around this is going to be helpful, because that negative is not applying just to the first term, just to that x squared. Because it is, it's also being applied to the x and the negative 6. We have to distribute this negative through the whole expression. Our first expression, the x squared minus 5, does not have a negative in front of it, so it's just going to stay positive x squared and negative 5. Questions on this so far? We need to come, where at? Because we need the denominators to be the same. This one's missing in. As an x plus 7, it's missing in. So we multiplied on top and bottom. So here, x plus 3 times x minus 2, give us this. Are the denominators the same? So that means we're going to be able to subtract our numerators. Here to here, we just combine like terms. So we're subtracting. I've got to apply that negative through. And that's it so far. Now, combining like terms, x squared minus x squared is 0. Negative x does not have any like terms, so it's just negative x. And negative 5 plus 6 is and that's as far as it goes. We could factor that negative out of the top, but it's not going to match up with anything on bottom. Questions on this here? Because the whole goal is to get the denominators to be the same. Once we get them to be the same, we add or subtract and simplify if necessary. Questions on 22? 23 is not going to, there's not going to be any one that has 3 expressions. It's only going to be like 22. 21 has 3 but doesn't have 3 because all the denominators are what? So it's really just add the tops. 23, we have 3 different denominators, so we have 3 different things we got to make them be the same. Yep, because the only way we can add or subtract fractions is if the denominators are the, doesn't matter what they look like, as long as they are the exact same. Here, the denominators are the same, so we can subtract or add the numerators at this point. Even if it's sets of parentheses, as long as they're the same, we can add or subtract. Yep. Least common multiple, we're just trying to get these to be the same. We want to see what the first expression that will make them be the same. Well, 26, 2x squared with this here, so factoring is going to be the first key piece. 2x squared is factored because it's a single term. 4x plus 12 does have a greatest common factor of what? 4. Yep, I don't know why I'm writing 2. 4. And if we factor it out, we get 4 times x plus 3. Because on all these here, these least common multiples, we need to factor them down as far as they'll go, and then see what we need to do to make them be the same. Because 2x squared is as simplified as it gets. Once we factor the 4 out, what we have left inside is x plus 3. No other common factors. And since the variable x has an exponent of 1, it's simplified. So we need to see what we need to do to make them be the same. So we'll look at the numbers by themselves, the numbers outside first. What's the first number I can turn both 2 and 4 into? Is it getting one up? It would be 4. The greatest common factor between 2 and 4 is 2. But when we're looking for least common multiple, we're seeing what would we need to multiply to get them to be the same. So 2 and 4, well, the first number I can turn both 2 and 4 into is 4. It would give us 4. The other thing we have outside is x squared. Huh? So really we're seeing what do I need to multiply both of these by to get them to be the same? What's the first expression we can make them both be? Yep. Yes. X squared, since the 2x squared has an x squared, the 4 times x plus 3 doesn't, it has to have an x squared. What else are we missing? is with our 2x squared, we need to multiply by 2 and x plus 3. Our 4 times x plus 3, we just need to multiply it by x squared, and they are the same. Least common multiple is going to be equal to or bigger. So 2 has to come up to 4. 4 stays where it's at. 27, x squared plus 3x minus 40. This here will factor. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Now our factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. 5 and 8. 8 is going to be positive, 5 is going to be negative. Now the other expression they gave us, x minus 8, that's as simplified as it gets. No greatest common factor, degrees 1, that's it. Let's look at the factors. This one here has 1x plus 8. The other one doesn't, but we'll need it at least once. We'll also need an x minus 5 once, because one of them has it as a factor one time, yes? Any other factors that are listed that we don't have listed? If the other one had been x plus 8, it is listed in both. But since it's only listed in each one of them once, we only need it listed once. Because if it shows up more than once in one of the sets of factors, we need it more than once. Let's look at 29. Let's start with the 4x squared minus 16. Between these two here, they do have a greatest common factor of what? 4. Always start with greatest common factors when we're factoring. Always start with greatest common factors. And x squared minus 4 is a difference of perfect squares. And it factors the x plus 2 and x minus 2. So it completely factored as 4 times x plus 2 times x minus 2. Okay. Our other one. There's a greatest common factor of 6. We'll factor it out first. And x squared minus 4x plus 4 will factor. Since the third term is positive, the signs are the same and match the sign of the middle term, so we'll have negative and negative. Factors of x squared are x and x. Factors of 4, 4 and 4 are 2 and 2. The one that we want is 2 and 2. I'm going to save the 4 and 6 for the last bit because I think it's nicer to work with least common multiple with our factors, our parentheses. So if we look at this here, let's start with x minus 2. The one on the left has x minus 2 once. Twice. So since it does show up in one of these two twice, the least common multiple is going to need it twice. It does show up in each one of them once, but because it showed up in one of them twice, we need it twice. What other factor do we need?
So if there's at least 2 of them, you don't like so there's only one.
Right, because even if it shows up in both of them once, we only need it once. Because really, 4, if we broke it down in its product, is 2 times 2. So we have 2 twice, yes? 6 is what? 2 times 3. So 2 shows up in one of the factors twice, so we need it twice. Well, 2 times 2 is what? 4. What other factor are we missing? The 3, yes? 4 times 3 is With any of these here, factor them as far as you can, because you will get points at least for factoring and then trying to get there. Solving. Solve each of the following equations. Which one of these do we want to look at first? 31? Yeah. So we need the least common denominator. What we need to multiply through to get the denominators to cancel out. Well, the first thing I would do is make sure all the denominators are factored as far as they possibly can go. X plus 6 is simplified, 2x is simplified, individual terms. So one of the things I can multiply everything by first is x plus 6. On the right-hand side here, the x plus 6 and x plus 6 would cancel. Are all the denominators gone? No, what do we still have? 2x. That means I can multiply both sides by 2x also, which is going to make the 2x on the left-hand side cancel out. And what that leaves us with is 4 times x plus 6 is equal to 5 times 2x, which is 10x. So really with all the solving, we multiply through and solve what we have left. On the left-hand side, we can distribute the 4. 4 times x is 4x. 4 times 6 is 24. Now, since we don't have any x squared terms, or have a power connected to x greater than 2, we can get the variables by themselves. So we can subtract 4x from both sides, which will leave us with 24 on the left-hand side. 10x minus 4x is 6x. Last but not least, we can divide both sides by 6, knowing this x is equal to 4. The only ones you really need to list restrictions on, especially with solving on the test, and I'd be looking at the instructions. If it says check your solutions, check your answers, definitely find the restrictions there. Those are the only ones where the restrictions are going to be important. Any other questions on 31? All right. If we have time, we'll come back for 32. Because I do want to look at 34. It's going to be very tempting on 34 to multiply everything by x plus 1 and x squared minus 1. X squared minus 1 is factorable. And with problems like this here, we're not too concerned if the numerators can factor. We're more focused on the denominators, having them factored as far as possible. And x squared minus 1 is a difference of perfect squares. X squared would be x and x. 1 is 1 and 1. So we have x plus 1 and x minus 1. And again, when factoring, always look for greatest common factor first. Always be looking for the greatest common factor first if it has one. Here, x squared minus 1 doesn't. Now that we have those, we can start multiplying through to reduce our fractions. So the first thing we can multiply everything by is x plus 1. On the far left side, the x plus 1 and x plus 1 would cancel. In the middle, the x plus 1 and x plus 1 will cancel. Now, unfortunately, with the 3, since it doesn't have a denominator, nothing's going to simplify. Now, the middle expression still has a denominator. So we also have to multiply this by x minus 1, which means everything else has to be multiplied with x minus 1. So for this here, we had to multiply the entire equation by x plus 1 and x minus 1. Is going to end up being the only term that doesn't have anything multiplied by it, because everything we multiplied it with simplified with its denominator. Now we will have to multiply everything else out at this point. Here we're going to distribute the 4x. 4x times x is going to be 4x squared. 4x times negative 1 is negative 4x. 1 times x is going to give us plus x. And lastly, 1 times negative 1 is going to give us negative 1. On our other side, we're going to multiply our x plus 1 and x minus 1. X times x would give us x squared. X times negative 1 would give us negative x. 1 times x is going to give us plus x. And 1 times negative 1 is going to give us our negative 1. Questions on this here before we start combining like terms? Now our negative 4x plus x is going to be negative 3x. On the right-hand side, our x squared doesn't have any like terms, but our negative x plus x would be 0, giving us x squared minus 1. Now, before we can start getting everything on the same side, we are going to have to distribute in 3. 3 times x squared is going to give us plus 3x squared. 3 times negative 1 is negative 3. Are there like terms on either side of the equal sign? Yeah. 3 times negative 1. This is where we got this for negative 3 from. That make sense? Okay. Yes. Now we do have to combine the 3 and 12, the negative 3 and 12, which would give us plus 9. Now we do have an x squared term. Actually, we have 1 on either side, which means we're going to need to get this equation equal to 0. I would move the x squareds first, just in case, because there are some times, if we're lucky, that when we get the x squareds on the same side, they'll sometimes cancel out. Here, unfortunately, they don't, because 4x squared minus 3x squared is just going to be 1x squared. Then we'll subtract 9, telling us that x squared minus 3x minus 10 is equal to 0. All the problems on this test are solvable by factoring once we get it down to if we have a quadratic at this point. And we can factor it. Since the third term is negative, our signs are opposite. Factors of x squared are going to be x and x. Our factors of 10 are 1 and 10, or 2 and 5. So we can do 2 and 5. If I want to check and make sure, we can check off to the side that we do get the correct middle term of negative 3. X times 5 is going to be negative 5x. 2 times x is positive 2x, giving us the negative 3x middle term that we wanted. Questions on this so far? Now, the reason we got it into factored form is that we have two things multiplied together to equal 0. So one of these has to be 0. So we're saying that either x plus 2 is 0 or x minus 5 is 0. Yes. So for x plus 2, we would minus 2, telling us x is negative 2. For x minus 5, we would add 5, telling us x is equal to 5. So the big thing with this here is finding that least common denominator, that set of terms we multiply through to get the fractions to go away. Questions on this here? Questions on 35 or 36? Thirty-five, 36, any one of these that y'all want to see worked or have questions on? Okay. So if we look at 35, each of the denominators are simplified as it gets. 3x and 6, there's nothing we can do that get it simpler than that. So we do know for sure I'm going to have to multiply everything by an x. But now the question is the 3 and 6. Because I could multiply everything through by the 6 and the 3. But what's the first number that I can turn both 3 and 6 into? If we multiply everything by 6, x, well, the nice thing is the x and x will cancel out. X over x, not that one. That one's fine. That x is going to stay. But here we can see that this 6 and this 6 will cancel nicely. Those are easy to see. Now what that leaves us with is 2 times 6 over 3 plus x is equal to 4 times 6 over 3. Here we have 6 divided by 3, which is what? 2. So really what we have here is 2 times 2 plus x is equal to, well, again, we have 3 over 6, which is just 2. Well, 2 times 2 is 4 plus x is equal to I put this middle step here just so that we can see how that's using 6 will reduce that out. But that's it. Questions on any of this so far? We can go back over it if we want. Let's look at 38 first. Now 38, we will need to factor one of the denominators first. The x squared plus x minus 6. X squared plus x minus 6 will factor to x plus 3 times x minus 2. Now this one here, I'm going to go on and list the restrictions. So the restrictions for this here are anything that's going to make the denominator be 0. So for us here, there's two places where the denominator could be 0. One of them is at x minus 2, and the other is at x plus 3. Now even though the x minus 2 does show up in two places, its value that will make it 0 is going to be the same for either one. And at this point here, we just need to solve both of these to see what's going to make it be 0. So for the x minus 2, we would add 2, telling us that if x is positive 2, the denominator would be 0. And if we get that as a solution, we throw it out. The x plus 3, we would subtract 3, telling us that x cannot be negative 3. So if we get positive 2 or negative 3 as a solution, we just mark it out because it does not work. Now let's see what we need to multiply everything by. So what's one term we need to multiply through by? X minus 2 and x plus 3. Now on the far left, the x plus 3 and x plus 3 would cancel, and the x minus 2 and x minus 2 would cancel. Our 2 in the middle doesn't simplify with anything, but on the far right, the x minus 2 and x minus 2 would cancel. Now what that leaves us with is 5 on the left-hand side, because everything we were multiplying it with simplified out. Yeah.
Mine's negative 5. Yeah, ours is.
I think I might have changed it to positive 5. Yeah.
So you want ours positive?
Possibly. Yeah. I can't remember if I changed yours or this. I'll see here in a second. Yeah. We'll leave it as 5 for now. Questions on this so far? Now at this point here, we're going to have to multiply our parentheses out. So the first one we're going to multiply through is this here. X times x would give us x squared. X times 3 is going to be plus 3x. Negative 2 times x is going to be negative 2x. And negative 2 times 3 would be negative 6.
Wait, how did you get the 6? Oh, wait, just. Okay, wait, so you multiplied the x.
Plus. We're going to do it again.
You multiply just by the 2. That's what I was thinking.
This 2 is only going to go to one of them. It's better to save it to the end. Because we can multiply that 2 with the x minus 2 or the x plus 3. We can't do it with both. So might as well leave that scalar, that 2 out front to the end.
So if you have to parentheses next to each other.
I'd rather just multiply those first. Now the x minus 3 times x plus 3. X times x would be x squared. x times 3 would be plus 3x. Negative 3 times x would be negative 3x, and negative 3 times 3 would be negative 9. Now we need to combine like terms, yep. And a negative 3x and positive 3x in our other set of parentheses would cancel each other out. Now at this point here, now we'll distribute the 2 through this parentheses. 2 times x squared would be 2x squared. 2 times x would be plus 2x. 2 times negative 6 would be negative 12. Now at this point here, we can combine like terms. 2x squared plus x squared with 3x squared. There's nothing that combines with 2x, so we just have 2x. And negative 9 minus 12 is going to be negative 21. At this point here, we do need to get this equal to 0. Because that's... Yes. Okay, yep. So we're going to subtract 5 from both sides. I see, yes. Okay. I changed jaws and not this. Because this is what was... Because this here would give us negative 26. I want to change it because it will work. We will get solutions. They'll be irrational solutions. But if it's negative 5, we add, giving us 3x squared plus 2x minus 16. Having it be negative 16 is going to work out better. So we would have our 2 sets of parentheses with 3 spaces. Since the third term's negative, our signs would be opposite. Factors of 3x squared, well, the x squared would be x and x. 3 and 1. You just got to pick a place to put the 3. Factors of 16 are 1 and 16, 2 and 8, 4 and 4. Which one do we want to try first? Just pick one. 4 and 4. Because again, we can check and make sure. 3 times negative 4 would be negative 12x. 4 times x would be plus 4x, giving us negative 8x. So we can go 2 and 8. I'd put the 8 away from the 3, because we do have to multiply it. 3x times negative 2 would be negative 6x. 8 times x would be plus 8x, giving us a positive 2x. Actually, I think that's what we want, isn't it? Yeah. Now, if it had given us a negative 2x, then yes, we would switch the signs. Since we have 2 or more things multiplied together to equal 0, one of them has to be 0. Now, for our 3x plus 8, we can subtract 8 from both sides, telling us 3x equals negative 8. Divide by 3, telling us x is equal to negative 8 thirds. Our x plus 2, or x minus 2, we would add 2, telling us x is equal to 2. Now, since x equals 2 is one of our restrictions, we cross it out, leaving us with negative 8 over 3. And that's it. So tomorrow is going to be part 1, which is everything except for solving, and part 2 is just solving. So if you have any other questions, please